Right, so explain the difference between an indefinite integral and a definite integral. Okay, so this leads us to what we actually use integration for. Okay, and it's quite a powerful process, just like differentiation. If you think back to differentiation for a moment, what was the point in doing it? What was the point? Well, if you remember, when you differentiated, you just found dy dx. If you remember, that function we called the gradient function, yeah? Because it actually gave the gradient at any point on the curve. In other words, it told us the steepness of it, the slope. So the tangent here, okay, would be the gradient at that particular point, and we could discover it by doing dy dx. Okay, well, integration has actually got a powerful approach, okay, a powerful application, just like differentiation has got a powerful application. So differentiation, we can find the gradient of the curve. With integration, we can find something about that as well. With integration, when we use that symbol there, yeah, we can actually find the area underneath the curve. Okay, so if you actually integrate the curve equation, it will give you the area in terms of wherever you want it. So suppose I wanted the area of this curve here between, say, 1 and the value 1 and 3. Okay, I can actually work it out by integrating that curve. Okay, and then by performing a calculation, okay, I can determine the exact area under that curve. Okay, of course, because it is a curve, this isn't a particular shape, isn't it? You know, you might look at that and think, well, it looks a little bit like a trapezium if I turn it around. Okay, but it's not a trapezium, isn't it? Because it's a curve there. So this process of integration will actually work it out exactly for us. Okay, so that's what we're going to use integration for. So it's good, isn't it? We've got differentiation to work out the gradient of the curve at any particular point. We've actually got integration to work out the area of the curve wherever we want it. In this case, if we want it between 1 and 3. Now let's explain the difference then between an indefinite integral and a definite integral. And quite simply, suppose I want to integrate the curve y x squared plus 2. Okay, suppose I want to integrate that. Okay, this would be known as an indefinite integral. Okay, because when I integrate it, I'm just given this and I'm asked to integrate, and you do the same process as we've just learned. You add power to that, so you get x cubed, so you add 1 to it, so you get 3, divide by 3, and then of course 2x then we get from here, and then plus a c, and we leave it like that, right? That doesn't give us an area, doesn't it? That just gives us this function here. So it doesn't actually give us an area, it doesn't give us a numerical value. So this is what is known as an indefinite integral, okay? Now, a definite integral is when we're actually going to work out the area and we're going to get a numerical value. And when we do that, we have to sort of describe then the area that we want. Okay, so in this case, I'd want the area underneath the curve between 1 and 3. If that makes sense, yeah? I'd want it between 1 and 3. So what you would do then is, when you draw your integral, you'd put the lower sort of value here, where we work in the area from. So we call that like the lower limit. And we put that value there, 1. And we then put the upper sort of value then, the upper limit, we call it here, 3. So what I was saying is here, I'm now going to work out the area, okay, underneath the curve between 1 and 3 of this, okay. And you end up then with a numerical answer, okay. Now I'm not going to do it now, I'm going to do it in the next video, but you do get then a number, basically, okay, or value, right, which will be the area under the curve, okay. Now, because then you actually get an actual answer, numerical value, we call it a definite integral, okay? So that's what we call a definite integral there. And the good thing is, when you're asked to work out the area, when there's limits being used, you do not need to write plus c, Okay, so we need to write a plus c for indefinite integral, but for definite integral, there's no need for plus c at the end. Okay, there's reasons for that, okay, quite simple reasons. I won't go into it now, but there's no need to write a plus c when we're actually working out the area. Okay, so we'll see in the next video how we can actually go about working out the area.